Hello everyone, today we're looking at impulse and Newton's second law. The formula for impulse goes as follows. F net times change in time is equal to change in momentum. So what this means is this part over here, that is impulse. And this part over here, that is also equal to impulse because of this equal sign over here. So what impulse really is impulse is a net force acting on an object for a period of time. So for example, if you had two objects colliding with each other, one object is over here, one object over here, then they collide with each other. Both of these objects are exerting a force on each other. Say the collision lasted for 0.2 seconds. The impulse would be the magnitude of that force which they exert on each other multiplied by the change in time, which is this over here. And that is what we call impulse. This is also equal to change in momentum. So we've looked at momentum in previous lessons, and whenever an object collided into something else and its momentum changed, we used the change in momentum formula to figure out what that change in momentum was. But did you know that impulse is actually what causes the change in momentum, and that's why impulse is equal to change in momentum. So then it should make sense to you when I say that the units for impulse are going to be exactly the same units we use for change in momentum, which is kilograms times meters per second. Okay? So if you're ever asked to calculate impulse and you have the change in time and you have the net force, you always have a way of calculating that impulse. Furthermore, if you have the change in momentum, you also have a way of calculating impulse because impulse is exactly equal to change in momentum. So let's just use the same example over here. Let's say that this block A exerts a force of 35 newtons on block B. Now, if I asked you to calculate the impulse over here, you would take the net force and you would multiply it by the change in time. See how simple it is? So let's do that over here. Let's take the net force, which is 35 newtons, and multiply it by the time during which the objects were in contact with each other. Remember, these objects, they collided with each other and then afterwards they moved apart. But for 0.2 seconds, these objects were in complete contact with each other. So they were touching each other for those 0.2 seconds during which they exerted that force on each other. So 35 newtons multiplied by 0.2, and that gives us a value of 7 kilograms per meters per second. And that would be our impulse over here. Okay, now let me show you something very interesting about the relationship between impulse and Newton's second law. If we wanted to rearrange this formula, we could put it like this, where we have F net on one side and then change in momentum over change in time on one side. Would you agree with me that this is exactly the same as that over there? We've just taken the time over to the other side by dividing both sides by delta time. Okay, now we can rearrange this formula again because we know that change in momentum is equal to mass times velocity final minus mass times velocity initial. And that is over time. So once again, this is exactly the same as that, and that is exactly the same as that. So now what we can do is rearrange that formula again. We'll take the mass to the outside and then have velocity final minus velocity initial over time. Now, doesn't this look familiar to you? This is actually the formula for acceleration. And what do we get when we multiply mass times acceleration? This should be really familiar to you. You've got it right. It's actually Newton's second law. So really, this whole thing over here is just this over here, but it's worded, or it's like in a different format. It's actually the exact same thing. The formula for impulse and Newton's second law, it's just rearranged differently.